Hello, my dear students. I welcome you all for the online learning platform through Diksha application. I am Shashidhar, lecturer in electronics at Vidyamandir College, Malleshwaram. Today, I am going to teach you network theorems. Network theorems. Why we need? The first question arises. We need to understand the importance. A theorem will give us a solution. A complexity can be reduced into a simplicity. Very simple how we can convert. That is the agenda of the network theorems. Here we have three theorems in syllabus, that is superposition theorem, and then Thevenin's theorem, and then maximum power transfer theorem. These three theorems we have in syllabus, and let we learn today the first theorem, that is superposition theorem. As the name indicates, superposition means what exactly? Superposed means, what is the general meaning of superposed? When two or more acting simultaneously. What is the contribution from each and every independent? That is what we need to analyze. That analysis can be done by very simple way by using this particular theorem known as superposition theorem. Okay, very first let me understand the main purpose of this theorem. See here, two or more sources are acting simultaneously. I mean to say, there are two or more sources are present in an electrical network, and that we need to calculate what is the contribution from each and every independent sources are acting at a time alone. Okay, that is the theorem, and finally we are going to consider the resultant will be sum of the each sources acting independently. We need to consider it as a result. That is what superposition theorem. Okay, here we can understand this simple network. There are two sources, and these two sources are acting simultaneously, and it is very essential to calculate what is the resultant current or voltage through a branch when each source acting independently. Finally, what do? We need to consider, the final consideration is what? Sum of the, I mean to say, resultant. We are going to take the summation, means sum of the each and independent sources contributions will be considered. Okay, come to the statement of the theorem. The statement is very simple. Please try to understand. Any linear bilateral electrical network containing two or more independent sources, the resultant current or voltage in any branch is the algebraic sum of the currents or voltages caused by each independent sources are acting alone, with all other independent sources are being replaced by their internal resistances. You can try to understand here. What are the things we need to do here? Means we have to consider a single source. By that time, other source has to be replaced by their internal resistance, and vice versa we need to do for the second source. Like first source we need to do, by that time second source has to be replaced by the equivalent, what exactly the internal resistance will be there. When we are going for analyzing, the analysis will be done for second source, means by the time first source has to be replaced by their internal resistance. So henceforth, this theorem we need to understand the finally what it is, the resultant current or voltage in any branch. How do you find? That is what you can say. That is what means, that is algebraic sum of the currents or voltage caused by each and independent sources are acting alone when all other independent sources are being replaced by their internal resistances. This is the theorem, and this theorem will give us the knowledge how superposition can be applied. Okay, thank you, students.